All right, so this next section we have preparing a compounded prescription from a formula. So if you're following along in the book, we are on page 387. Once again, we're just kind of combining some skills that we've already learned. So here we have a recipe, very similar to recipes that you'd see in the real pharmacy here. So we have 2 grams of tetracycline powder, 45 mils of nystatin suspension, 76 mils of diphenhydramine, and then we're going to QS to 240 with our dexamethasone solution here. So it's very important to understand that we don't know exactly how much dexamethasone we're going to be using. We're just going to be adding enough dexamethasone to get us up to that final 240 milliliters here. The reason why this is because our tetracycline powder is measured in a weight measurement. And when that powder is dissolved, it's going to take up volume of its own, and we cannot determine exactly how much volume that will be. So that's why we're going to QS, or basically add enough at the end of our dexamethasone to get us up to 240 mils, which would be the final volume of this mouthwash compound. Okay, so this is really making a total of 240 mils. So anytime you see a recipe with QS to whatever volume, that will be your final volume here. Now, A says, what is the percentage of tetracycline in the final compound? Well, let's look at tetracycline. We know that there are 2 grams in this formula. And once again, the formula is making a total of 240 mils. So we know that there are 2 grams of tetracycline in our 240 mil solution. Now it's asking, what is the percentage of tetracycline? What is the percentage strength? Well, remember, percentage strength is always X over 100. So what I can do to find the percentage strength of tetracycline is just set this equal to X over 100, and then I can solve. So you're going to take 2 times 100, which gives us 200. Divide that by 240. That leaves me with 0.83, and I'm just going to round to the nearest hundredth. This is really repeating here. So that would be 0.83%. All right, so now, based on what we just did here, I would like you to solve for the percentage of the nystatin. So remember, our total volume here is always 240. So nystatin, you have 45 mils out of 240. We would just set that equal to X over 100 to solve for the percentage strength there. And then you can do the same thing for the diphenhydramine. What's the percentage of diphenhydramine? Well, there's 76 mils in the 240. Once again, we would set that equal to X over 100 for our percentage strength. Then it says, what volume of dexamethasone is needed to prepare the desired volume? Well, like I said, we cannot calculate that because we don't know what volume this powder is going to take up once it dissolves. So D is a little bit of a trick question. The answer here would just be QS to 240 mils with the dexamethasone. So add enough to get to our final volume that we would need. All right, so let's go on here to number 15. Dentist sends a prescription for a mouthwash to swish and spit for pain. Here we have lidocaine, Benadryl, and Maalox. Okay, so we have 3 different ingredients here. The SIG says AAQS to 240. Okay, so if you're following along in the book, at the bottom of page 387, it tells you that AA, and usually that has a line over that. That abbreviation means of each. And then remember, QS means quantity sufficient. So we're basically adding enough of each ingredient to make a total of 240 mils, okay? So we're gonna have equal parts of all 3 of these ingredients here. So it says, what volume of each medication is needed to make this prescription? Well, I know that there are 3 different ingredients and I need equal parts of each of them. So all we really have to do is take our total volume here and essentially divide that by 3 because we have 3 different ingredients. So 240 mils divided by 3 ingredients gives me 80 mils per ingredient. So anytime you see that AAQS, that just means add equal parts of each. So now I know I would need 80 mils of lidocaine, 80 mils of Benadryl, and 80 mils of Maalox. Now it says, what would be the percentage strength of each? Well, we know that there are 80 mils of each solution in a total of 240 mils. Remember, percentage strength is always X over 100. So I could just set that equal to X over 100. So 80 times 100 divided by 240 leaves me with 33.3 repeating. So 33.3% here. And that makes sense because 33.3 repeating, if you take that times 3, that'll give you 100%. Okay, so each of these is 1/3 of the total volume, right? 1/3 in a percentage is 33.3%. All right, number 16. Calculate the amounts required to make 4 ounces of the following formula. So here I have coal tar, 2 parts, zinc oxide, 6 parts, wool fat, 12 parts, and white paraffin, 25 parts. So I'm noticing here that these ingredients sound like they would be measured in a weight measurement rather than volume. None of these seem to be liquids. So when we're converting ounces here, keep in mind that that is a weight measurement here. This isn't talking about fluid ounces, okay? So we want to change that into a metric unit of weight, which you should know would be grams, okay? So 1 ounce is equal to 30 grams. So then 4 ounces would be 4 times 30, which would give us 120 grams. So that just makes sure that we're working with metric units there. Now it says, calculate the amounts required to make 120 grams of the following formula. So what we're going to do first is recognize that these are just given in parts. I have no idea how many grams each of these would be. That's going to be what we're solving for. Now, the last time we saw parts was in the lecture for alligation alternate, or the tic-tac-toe method. So the first thing we did after we found out how many parts of each ingredient we needed, we found the total number of parts for the whole compound. So that's what you want to do especially with any recipe in general. If it doesn't give you the total, you should probably start by finding that first, okay? So let's add all these together to find out how many total parts we would need. So 6 plus 2 is 8, plus 12 is 20, plus 25 would give me 45 total parts. Now, let's take a look at each ingredient individually. So with coal tar, I have 2 parts out of the total 45. And if you think back to that allegation alternate, once we had our parts over the total, we then took that fraction times the total amount we were trying to make. In this case, we're trying to make 120 grams. So 2 divided by 45, leave that in your calculator, and then take that times 120. So that leaves me with 5.33 grams here. So that would be how much coal tar I would need. So 5.33 grams. So then we're just going to do the same thing for each of our ingredients. And if this is not enough room, I completely understand. You can write out the rest of these on scratch paper if you need to. So zinc oxide, we know that there are 6 parts out of the total 45. And then I would take that times my quantity of 120. So 6 divided by 45, leave that in your calculator, then take that times 120, leaves me with 99 repeating. So I'm actually going to round that to 16 grams. And that was our zinc. I'll label this one too. That was coal tar. All right, so I would need 16 grams of zinc. So what I'd like you to do now, do the same thing for the wool fat. So solve for this one here. And then also for the paraffin. So once you solve for those two, all of these grams should add up to equal 120 grams, okay? I rounded this one to the 100th, so if you get decimals here, I would like you to also round those to the nearest 100th, unless it's like the one that we had here that was 0.999, would just round that to 16 in that case, okay? So go ahead, solve for the fat, solve for the paraffin, and then double check your work by adding these together to make sure that they equal 120 grams. After you do that, this would also be a good place to stop and work on practice problems D before you move on to the next part of the lecture.